Good morning, everybody, or good afternoon, depending on your time zone. I'm Christophe Goazoué from Pool Corporation, and I'm very pleased to welcome you to this webinar session dealing with filtration technologies applied to parts washing. As Global Marketing Manager for Automotive, I would like to share with you during 20 minutes my expertise on different types of washing machines through a few industrial case studies. Before starting the presentation itself, I would like to say that you can send me your questions via your Q&A text box. I will collect the question, and at the end of the webinar, I will address them as time allows. This webinar will be available on demand for 1 full year, so until June 2018. Sorry for my accent. I'm French. Nobody's perfect. Here are the topics we'll cover through this webinar. We'll start by a brief explanation about the reason why components need to be cleaned before the assembly. On this occasion, we'll come back on one of the first component cleanliness research studies ever carried out in the auto industry. Afterwards, we'll review the general principle of a part washing machine before providing you some guidance on the most appropriate filter solution for a few standard parts washing configurations. Finally, we'll end this webinar with the direct relationship existing between the efficiency of the part washing process itself and the component cleanliness assessment. This webinar will be available on demand until December 2017. The access link will be available from the automotive landing page on PAL.com. So, why do we need to produce clean components? For the last decades, fluid power systems have been submitted to more and more technical challenges. Service pressures keep rising up, warm-up cycles are getting shorter, uptime requirements from end users are higher, etc. To respond to these changing market trends, component clearances and tolerances have continuously and dramatically reduced. As a direct result of these market drivers, part washing has become a vital part of the manufacturing process. To deliver cleaner and cleaner components, the overall efficiency of part washing machines has improved over the years from a design perspective. Filters have obviously taken part of this design improvement with either a better filtration efficiency or a longer service life or both. Now, let's go a little bit further, considering this time the effect of contaminants on the components themselves. This graph is a historical one, since it really corresponds to the beginning of the component cleanliness concept. About 20 years ago, Renault and Peugeot started to investigate the benefits of producing clean V6 aluminum engines on their reliability and performance. Results were very surprising since they demonstrated the impact of initial component cleanness on the surface finish of the piston cylinder liner. In fact, there was simply a factor of 1,000 in the number of contaminants embedded in the cylinder liners between the pre-washed engine and the production engine. You can imagine that these two engines will not exhibit the same overall performance long term in terms of combustion efficiency, petrol consumption, etc. Damages are simply irreversible. This first research study in which Paul took part was the very beginning of the component cleanliness management concept. Design, build, and keep it clean. Of course, today, the impact of component cleanness on assembled systems like injection or steering systems is by far much better understood. Now, let me quickly emphasize the main characteristics of a part washing machine from a contamination viewpoint. A part washing machine is an open system submitted to a continuous ingression of solid and liquid contaminants. Also, compared to a standard hydraulic system, the fluid operating conditions are not steady over time. There is a lot of evaporation above 50 Celsius, for instance. A too high concentration of trump oil can affect the washing properties of the wash fluid. The quality of the fresh water and the detergent mixed up can also influence the overall washing performance over time. The table gives you some guidance for a few key fluid parameters like the trump oil concentration, the filtrability of fresh water, the pH, etc. Sorry for those who are familiar with part washing. They will find this slide very trivial. just before going into further details on the filtration technology, I just wanted to highlight the fact that there are three types of parts washing machines: immersion, ultrasonic, and spray. Immersion is the most common technique used in automotive for small machine parts or finished goods. Ultrasonic is used for small and critical components. Spray or pressure rinse is the most common technique for casting parts or large finished components. Immersion, and especially high-pressure water debriding cleaning machines, are critical applications since they usually require high-performance filter solution, which can be either premium bag filters or depth filter elements depending on the process itself and the target cleanness levels to achieve. To extend as much as possible service life for consumable filters, magnetic candles or magnetic separators can be installed offline as well, providing that contaminants are mainly ferrous particles. Now, let's spend a while on the filtration performance difference existing between a bag filter and a process filter element. One of the key points of differentiation is the way the filtration efficiency is measured. For bag filters, we usually talk about absolute ratings which result from a static test. The absolute rating is in fact the diameter of the largest hard spherical particle that will pass through a filter medium under specified test conditions. This is an indication of the largest opening in the bag filter. For process filter elements, we usually talk about beta ratios which result from a dynamic test. The beta ratio is defined as a ratio of the number of particles equal to or greater than a given size, x, in the influent fluid to the number of particles equal to or greater than the same size, x, in the effluent fluid. The schematic on the slide gives you some idea about the way the filter element is tested. Compared to the multipass test used in hydraulics, this test is single pass because of the absolute cleanup filter installed on the return line. To be very simple, I would say that every millisecond the size distribution of the particles is measured upstream and downstream the filter element. So every millisecond we measure beta ratio. For process filter element, the filtration efficiency is usually given at 5,000. So we talk about a beta ratio of 1,000 at 5, 20, or 70 micron, for instance. This slide is also very important since it puts in perspective different aspects of design and performance for three types of filters which are very common in industry: a size 2 bag filters, a 10-inch long pleated filter cartridge, and a size 2 pleated filter element. Even if the values reported on the two graphs are relative, they are very representative of what is seen in reality. First of all, let's consider the filtration surface area. Clearly, the bag filters exhibit the smallest filtration area compared to the other designs. The size 2 pleated element features by far the largest filtration surface area. So it's not surprising at all that it also exhibits the largest dirt holding capacity. That means a size 2 pleated filter element will have a much longer service life than a size 2 bag filter. We are simply not comparing apples to apples here. Before presenting the different types of part washing machine, I found interesting to talk about diagnostics and monitoring equipment. If operators want to control the contamination levels of their wash fluids continuously or during specific maintenance programs, I would recommend diagnostics and monitoring devices relying on the mesh blockage technology, which compared to automatic particle counters are not sensitive to free water or undissolved air. This proven technology enables operators to get an ISO code at the end of the measurement cycle. Basically, at constant flow and temperature, the delta P increase through the calibrated mesh depends only on the cleanness level of the wash fluid. This technology fits very well wash fluid applications, giving accurate and repeatable monitoring results. Given the time constraints inherent to the webinar format, I have adjusted this slide to describe the washing technique by agitated immersion. This is in fact the simplest washing principle in the industry. The wash fluid passes continuously through an offline cleanup filter, which is typically a bag filter or a depth filter. magnetic candles can be installed into the bag filters to retain ferrous particles. Here, the filter rating depends on the cleanness level to reach and maintain over time. This is what we call the RCL, for recommended cleanness level. It always depends on the component cleanness code to meet. Usually, it is defined by the manufacturer or the tier supplier. Again, low-pressure part washing machines are very common in the industry. Components are typically washed between 3 and 10 bar. The washing system is very simple, made of a reservoir and distribution line fitted with nozzles. Since the system is submitted to a continuous ingression of contaminants, could be solid particles, fibers, traces of coolant, etc., the wash fluid must be continuously filtered to ensure that its cleanness level is fully under control. That means is lower or equal to the recommended cleanness level. On such washing systems, back filters or depth filters are usually located downstream the pump to protect the nozzles against erosive wear. When the wash cycles are very long, tunnel washes are used to enable operators to wash many components at the same time. They are pretty common in the car industry. The purpose of this slide is to give you some guidance to select and size the appropriate filtration solutions for low-pressure parts washing machines. The wash fluid conditions, and especially the concentration of trump oil in the wash fluid, is a key parameter. Below 0.5%, depth filters or felt back filters are the most cost-effective solution to control the cleanness level of the wash fluid. Obviously, the dimension and the type of filters depend on the flow density, the ingression rate, etc. For large wash systems, size 2 pleated filters are the best solution in terms of service life. Above a 0.5% concentration of trump oil, depth and pleated filters are preferred. The goal is to avoid short service life because of premature clogging resulting from poorer filterability properties of the wash fluid. If back filters are used, select in priority a felt medium design and, at a lower level, a microfiber mesh design. In case of excess trump oil, the usage of an oil skimmer is highly recommended. I'll let you read the sizing rules for the different variants of elements. Filter ratings are related to the applications themselves. If the application is highly critical, consider components like injectors, servo valves, or precision bearings. You will select a filter rating between 5 to 40 micron. If the application is critical, consider components like pistons, cylinder blocks, or hydraulic cylinders. You will select a filter rating between 20 to 90 micron. If the application is what I call a general application, then filter ratings above 70 micron can be considered. By the way, select either filter elements or even back filters for pre-wash applications, for instance. Now, let's spend some time on the high-pressure water deburring and washing machines. They are by far the most sensitive systems from a maintenance perspective. If the wash fluid cleanness isn't fully under control, two things will happen. Firstly, the washing machine will see its efficiency reduced because of the gradual damage of the high-pressure pump and the erosion of the nozzles. This will continue until the complete failure of the high-pressure pump. Secondly, the component cleanness level will gradually increase beyond the upper limit set by the specification. To avoid such a dramatic scenario, appropriate filters must be installed, on the one hand to protect the high-pressure pump and on the other to maintain the fluid cleanness levels when the RCL will be reached. Two different types of filters must be considered. A depth filter element, which can be seen as a latch change filter to protect the high-pressure pump, which is usually very expensive. Some pumps can cost up to $75,000. When the fluid cleanness is fully under control, the maintenance costs are drastically reduced. A recirculation filter to clean up the system. Ideally, this filter must feature both a high flow density capability and a high dirt holding capacity. This slide is very interesting since it shows you the dual filter solution qualified by an OEM. The dual filter solutions enable SIM to adapt its technical offering to any market demands or any specific customer request. Thus, with only one filter housing design installed in the recirculation loop, the OEM can address the needs of both standard and highly critical applications with either premium back filters or depth-plated elements. The filter ratings are reported in the table. 10 to 20 micron for the depth filter elements on the debris line to protect the high-pressure pump. These filter elements can be considered as latch chance filters. 20 to 40 micron for either fail-back filters or depth-plated elements on the recirculation line to control the cleanness level of the wash fluid. The selection between bags and elements is based on the application itself. Is it a standard or a critical application? Appropriate adapters are obviously used to install plated elements into the back filter housings. Now, let's stay focused 1 minute on the pump itself. The high-pressure pumps are the most critical components of these debris and washing machines because of their very high sensitivity to solid contamination. As these pumps are very specific, they typically deliver fluid up to 450 bar. They usually exhibit a very high cost of ownership. Their maintenance costs can also be very high if they are not efficiently protected against large solid contaminants. Erosion is a wear mechanism responsible for the loss in pressure. In fact, solid contaminants erode both the ceramic piston and the nozzles, creating internal leakages. These leakages result in pressure loss and occasionally vibration of the pump, reducing the cleaning performance. In some cases, if these leakages are too important, they will stop the wash due to a low pressure alarm. I'll let you read the interesting comments made by Ford UK about the benefits of high performance filtration to protect the pump. Cat, Bartord, and Hammelmann may be the most common brands in the auto industry for these high pressure pumps. As we are getting close to the end of this webinar, I would like to reemphasize the direct link existing between the cleanness level of the wash fluid and the component cleanness level to achieve. Regular component cleanness assessments enable operators to know whether or not their washing process is fully under control or requires some corrective actions. Component cleanness analyses are relevant as they represent exactly what is getting out of the washing machine. At the end, components are in or out the specification. In conclusion, I would say that part washing is a question of good sense. Take a simple example in our everyday lives. At home, you use clean water to do the dishes after dinner. In the industry, this is exactly the same for parts and components, except the fact that the operating environment is by far much more complex and challenging. Every single component adds contaminants to the wash system. Appropriate filtration solution installed on washing machines will enable you to produce components within the cleanness specification, reduce reject rates, maximize the machine uptime and reduce the maintenance costs, and minimize fluid disposable costs. All right, so before addressing the questions that I've received during this webinar, I would like to thank you all for your time this morning or this afternoon, depending on your time zone. I hope that this webinar on parts washing was of interest to you. I remind you that it will remain posted on our website until June 2018. Again, don't hesitate to contact me via email if you need any further information. Thanks again for your attention. Have a nice day. Okay, everybody, let's start the question and answer session. If you have any concerns or if you want any further information, feel free to raise up and don't be shy. So you may be online. Any question at this stage? Everything clear? So I just want to emphasize the fact that this webinar will be available on demand on Pol.com until, I would say, February or March next calendar year. So feel free to promote this webinar within your, I would say, professional group. If you see any interest to share with one of your colleagues and so on, please don't hesitate. You will have the access link sent by email, I guess. Any question? Okay, so thanks you all. Have a great day, and again, keep in touch. Thank you.